Take out your Bell worksheet. At the very, very bottom, there were 2 questions we didn't do yesterday where you have those 2 ordered pairs and you have to find the slope. So here is the formula for slope. That you're going to use for these 2 questions. It's at the very, very bottom. So, and I know there's not a lot of space, but there is a lot of space off to the right. If you want to write it off to the side, that's okay. But here's your formula that you're going to use. Label your points. I always start by labeling my points. So you have your x1, y1, your x2, y2. Go ahead and find the slope. Who has an answer for the first one? It should be a whole number, not a fraction. Yep, so let's go ahead and walk through it real quick. Well, there really isn't a wrong way. If you did y1 minus y2 over x1 minus x2, that's still going to be okay. Yeah. So negative 4. So y2, which is negative 4, minus y1, which is 5. And that's all over x2, which is 3, minus x1, which is 2. So negative 4 minus 5 is negative 9. Negative 9 over 1, because 3 minus 2 is 1. So the answer is just m equals negative 9. Who had that for their answer for that first one? All right, good job. All right, now go ahead and do your second one. Label it x1, y1, x2, y2. Oh, it's not working. That's because it's not good. Oh, it's water. Oh, okay. We'll go to, yeah.
There's one over there still.
Yeah, there's still one over there too. Yeah, you can just use the one over there. Thank you for that. I don't know. Get some paper towel. So make sure that you're showing your work to get credit. Can you pass that back? Okay. So we have m equals, so we have y2, which is 5, minus y1, which is negative 1. That's divided by x2, which is 7, minus x1, which is negative 1. So remember, whenever you subtract the negative, these always change to addition. Okay, so this is the same as 5 plus 1 over 7 plus 1. So your slope would be 6 over 8. Who has 6 over 8? Did anybody reduce that? Because you can also reduce it. So what would be another way to write that, Alex? 3 over 4. I would take either one of those for full credit. All right, so let's go ahead and go. We have 2 examples to cover today. So on page 103 in your reveal books. Page 103, yes. So go to page 103. So one thing that you should be able to do at this point is take an equation and rewrite it in slope-intercept form. So I want you to take this equation right here, rewrite it in slope-intercept form. The one that I highlighted in yellow. So take this one right here that I have highlighted in yellow, solve that for y. So let's subtract the 7x. So that's going to give us, so this 7x is going to go across, changes its sign, becomes negative because we subtracted it. That's how we can get it to go across. And then lastly, to get rid of that 2, divide by 2. Good job. So your equation, when we rearrange this, becomes y equals negative 7/2 x plus 8. So the slope would be negative 7/2. The y-intercept is positive 8. So now let's do that with the second equation. I'm going to highlight that in pink. So you can write your slope as a decimal also. Whenever I'm graphing though, I usually keep it a fraction, but I would not mark it wrong if you wrote it as negative 3.5. So let's go ahead and take our second one. And let's do that together. So negative 21x minus 6y equals 24. So what's our first step? Oh, and not subtract the 21x. Yeah, we're going to take this, move it over, and it's going to become positive. And then we divide everything by negative 6. And we get y equals, and then that would be negative 21 over 6, x minus 4. But negative 21 over 6 can be reduced because you can divide both of those by 3. So you actually have y equals negative 7 over 2x and then a minus 4. So they put the plus so you can put the negative 4. So you just put a negative 4 on the line. When you subtract 4, that's the same as adding a negative 4. So what do we notice about these two equations? What do they have in common? They both have the same slope, which is negative 7 over 2. They have the same slope. But the y-intercepts, see how these two are the same, but the y-intercepts are different. So when that happens, that means that, who remembers, what do you call lines that have the same slope? Begins with the letter P. Parallel. Good job. Two lines with the same slope are parallel. And when you have parallel lines, they never intersect. So it doesn't matter how long we draw these two lines, they're never going to come together. They're never going to meet. So that means that there is no solution, because the solution is where they intersect. And if they're parallel, they will not intersect. So it has no solution. All right, let's look at example 4. So now we're talking about electric cars and gas cars. So it says the cost of an electric car, so we're going to talk about an electric car, is $29,000 to purchase, and it costs 0.036 per mile to drive, okay? So let's go ahead and write our equation right now for a electric car. So for an electric car, Y is going to represent the total cost of owning the car, and X is the number of miles driven. Okay, so for this equation, the slope, you see how this word per comes after this number? That tells me that that number is my slope. Okay, so our equation would be Y equals 0.036x, and then my y-intercept is how much it costs to buy it. And how much does it cost to buy it? $29,000. So you have your y-intercept and you have your slope. So now let's look at the second half. See if you can write that equation by yourself. It says that a gasoline-powered car costs $19,000, but it costs 0.08 cents per mile to drive. So go ahead and write your equation for... Yes. Oh. So what is the slope for a gasoline powered car? 0.08. So you have 0.08x, and then what's the cost to purchase a car that's gasoline? All right, so you see we got our two equations. Okay. Fortunately for us, because it would be really difficult to try to graph that, they graphed it for us, which is really good. So we have the blue graph, that's your electric car, and we have the orange, I guess it's orange. The orange would be your gasoline car. So notice it says the graph appears to intersect, because when it says appears to intersect, we have to approximate it. So let's just do our very best to approximate what we think these numbers are. What is X? 220. So on the test, for example, because again, all you can do is go off your eye. It's kind of hard to know exactly, right? We would actually have to do another way to figure out exactly. That's why you're approximating. The x-axis is counting by 30s. So it's between 210 and 240. So what did you say again, Lex?
220.
All right, I'm going with it. So 220. But what you need to keep in mind is that this is in thousands. All right, so you need to take that number and multiply it by 1,000. So add 3 zeros. So instead of 220, we would say 220,000, right? Now, I want to make sure you understand that if Deshaun said it was 230, that's good enough. If Kenneth said it was 235, we're still good, because we're approximating it, okay? You should just have a number between 210 and 240, okay? 210,000 and 240,000. So now let's go across. What would be the Y value? So the Y value looks like we're counting by 5. So it's a number between 35 and 40. So what number are we going with? 37. Sounds good. And again, notice how it says thousands. So it's 37 times 1,000. So it would be 37,000. Okay, so what does that mean? This means that if you're planning to drive the car and drive at least 220,000 miles on it, the cost of owning the cars will be the same. So after 220,000 miles, the cost, this is important, is going to be the same. It started off that an electric car was more expensive than a gasoline. But when you hit 220, they're the same. That's called your break-even point. All right? All right, use the rest of this time to work on your homework 11, which is due on Tuesday. But you also have homework 10, which is due Friday. If you have questions, use this time wisely to get help